In this video, we're going to be looking at how we can create these kind of sharp, convex details in geometry under subdivision. And you can see we have quite a few of these going on in this shape. And this is part of a guitar capo. And we can see a reference of this shape. And what I essentially did is trace round this in geometry. And while I'm doing this, I'm trying to think of how I can manufacture these kind of sharp details. Now you may think to yourself, Toby, why are you doing this in geometry? You could do this with a spline. Well, you could do with the shape, but the fact is that we have this detail kind of tucked in round the back, and obviously we can't manufacture this with a spline and extrude object. We have to roll our sleeves up and get into modelling some actual geometry, and it's very easy to do this kind of thing under subdivision. And even though this is a hard surface object, we can still use subdivisions to our advantage to manufacture these kind of shapes. So what I'm going to show you is the basic techniques behind going between these kind of smooth curves that we see here into these kind of sharp angles. And these are the techniques we'll use when we're creating shape profiles. Now to do this, I'm just going to start with this 2x2 plane. And to add a bit of curvature into this, I'm just going to grab these three corner points, hit T, and use kind of sticky keys here to bring some curvature into this geometry. So when we subdivide this, we get this smooth curvature running around here. And then where we have this sharp corner, we have less curvature in this area, obviously, because of this square polygon. Now, when we were sharpening our edges, we know that we need to place a control cut around the edge of an object if we're going to have some sort of transitional line. The main end game is to obviously extrude this geometry down, so we'll want to sharpen this transitional edge. Now, when you're making 2D topology and mapping out your shape, it's a good idea to try and think ahead about what kind of transition you're going to have and actually model the control cut for this surface into your geometry before you extrude it. Now usually you do this by working out the rough shape, then grabbing all your geometry, hitting I for inner extrude, extruding inwards to create an edge loop around your geometry. Now you'll notice that when I did this, the shape didn't change, and this is because we have an edge loop, and the edge loop still promotes curvature in our subdivision, so we won't see any kind of sharpening in the profile of the shape. Now we do this because we want to create something quite important, and this is this loop of edges here. And we generally call this a support loop. And we call it this because it's going to support the geometry that we're going to cut in to sharpen some of these areas. Now without this edge here, we have to really start cutting in to our geometry pretty much to the middle, because that's the only place there's really a point that we can cut to. And also the other major factor is here that we're actually cutting a control cut around the top surface of this object. If the edge flow is promoting this curvature, it might be a good idea to actually break this edge flow to sharpen our geometry, and that's pretty much exactly what we do. I'm going to demonstrate this on the corner here. We've obviously seen this before, where we have this diagonal edge that's feeding the edge flow round. And what we want to do is essentially get rid of this diagonal line. So we're going to cut a square box into this corner. Then we're going to grab this edge and we're going to melt it. And immediately you can see the result of this cut. And this geometry has sharpened up. And this is because these two edges here are now the control cuts for this corner. And this is pretty much the standard way of cutting a right angle corner. Now, if we were to extrude this outside edge down and create what would be a control cut for this new surface, and then extrude down to create the surface, we obviously get this effect where we now have this sharp corner. We've sharpened our transitional edge around the shape. But the most important thing is that we've managed to sharpen this detail. And we've done this by creating what I call a box cut. Now, I don't think that's the right terminology, but that's what I call it because it looks like a box. And I'm sure everybody's familiar with this kind of topology from doing a solid chamfer on simple geometry, etc. So this method is extremely good at cutting these right angle corners. But it's also very good at cutting any kind of sharp feature around these kind of transitional edges. Now this kind of took me a while to figure out because it doesn't quite present itself as plainly as this square polygon down here. One thing I want to say before we go on is that if I grab my ring selection tool, and you can see I can select this outside loop of polygons, but this is actually an optical illusion, because if I try and select this edge with the ring selection tool, you see that it doesn't make the ring selection. And the same on this edge too. In fact, if I grab this edge, I'm not getting a ring selection, which is weird because I'm getting one here. This is because the edge flow around this outside loop of polygons is now starting here, travelling all the way around our shape, getting to here, and then it's intersecting the edge flow that's going this way over to here. Now, wherever you have an intersection in edge flow, you won't be able to select the loop. So if I go to polygon mode, select the loop tool and select this polygon, you can see that no loop is being selected. But as I kind of move into these polygons, it's trying to make a loop. And this is because these two flows are essentially intersecting each other. So if you ever go to select something with the loop tool, the ring selection tool, and it's not making the selection, it might be because you have a crossing or an intersection in your edge loops. So that's something to watch out for because it can happen and you'll be scratching your head going, why can't I select this? You can see that if I get my knife in loop mode, if I try to cut around this loop, it's actually terminating just before the intersection. So just something to watch out for there. So let's have a look at this area here. I have this edge situated here. Anywhere I have an edge, I have the potential to sharpen that area. So I obviously have one here, I have one down here. Basically on all these kind of corners around my shape. So wherever I have an edge, I can cut in some sharp detail. And I do this by just simply adding a quad to this geometry. Now it doesn't have to be square. What I could do is follow this line down like so and cut in here, follow the other line across and cut in here, grab the edge and melt it, and now I have a quad here. And obviously this is sharpened up this detail. Now you don't have to follow those edges, you can cut in pretty much any shaped quad you want. Let's cut something that's quite tight. Grab the edge, melt it, and here we have another quad. 1, 2, 3, 4. And you can see this time, this kind of shape has given me a really tight detail. And this is because the distance of these points to our corner point are pretty short. And they're obviously much closer than the kind of curvature we have here, because these points are obviously farther away from the corner point. So this is an extremely effective way of adding this kind of detail around the profile of a shape. Anywhere you want to set some kind of sharpening detail, we can add one of these quads, and this is the kind of outcome that we get. In doing this, we've essentially broken the edge flow around this shape. If I go to polygon mode and select around these outside polygons, you can see that the loop is terminating wherever we have these quads. So what if you want to maintain edge flow around this support loop that we put in? Well, in order to do that, we need to use a different kind of cutting method using a slightly different set of geometry. Now, just like before, I'm going to need to support this new geometry, because what I'm about to do is actually set all of this detail back a loop into this geometry. So I need to select these 4 quads. I need to inner extrude again. Now you can kind of go in as far as you want really. I'm just going to cut this pretty fine. Just going to cut this in point mode so you can kind of see what's happening. And I'm going to move in to this area here. I'm going to grab my knife tool in line mode. So what I want to do is put this quad here. I can do that really easily just by cutting into this mesh. Now you can see where we have an area of high tension here. Our subdivision is quite prone to errors, and we can immediately see an error in our geometry crop up here. If I do display Garud shading lines, we can see that our subdivision has sheared, and it's sheared because we have an n-gon here. And this is the kind of thing that n-gons do to subdivisions. An n-gon will actually subdivide into quads, but it will wreak havoc with the surface tension of the subdivision surface in some cases. I think the mantra of this course is let's get away from n-gons, as this is the kind of thing they will do. Let's go back to our other shading, and let's get rid of this n-gon by cutting an edge into here. So now I'm going to cut another cut here, and what I have here is a quad. It's 2 triangles at the moment, but I'll be dissolving that edge in a minute. The only thing I have to do now is support this point here, because I'm going to dissolve these edges. And if I dissolve these edges, I'm going to get a really bad n-gon. So I need to support this edge here. Now basically I have 6 triangles. Now if you have 2 triangles, it will make a quad, so we should end up with 3 quads here. Let's get our move tool in line mode. Let's select these edges and let's dissolve them. And now we have our new cut geometry. Our curvature hasn't changed because the points are in the same place. We've moved the quad that was here back a loop and use this quad as a starting point for these new edges, which are essentially cutting this curvature into our shape. So now we get something that looks like this. And I also have edge flow moving through this area. So let's cut this a couple more times so you can see it in action. I'll do a little bit faster this time. So I move this kind of diamond-shaped quad back a loop, cut into my edge points that are creating the detail, support the corner point, Get rid of these old edges that are making the triangles and dissolve. And now you can see my edge flow is travelling much farther round this shape. There's another one done. Then we can come to this corner. Let's support the edge first. And then bring our new edges in, dissolve the old ones. Now we've managed to establish edge flow around this support loop again, while cutting this detail into this shape profile. So what we could do is grab this outside edge, extrude down to create a support loop or a control cut, and now we have this kind of effect, which is how we would cut this geometry in. Now you don't actually have to maintain the edge flow around this for this to work, because you generally cut this sort of detail in at the end once you've already established edge flow in your topology, so it doesn't really matter if you break it with these kind of shapes at the last minute. This might be actually quite useful though. What we could do is select this ring of edges. We could get our knife cut tool, cut a kind of a channel into here, and what I'm going to do is I'm going to inner extrude this. And then move this down to create a channel. Now, if you're ever going to normal map something and you want to project a normal map, it's a good idea not to make these kind of insets with 90-degree angles. And I'll show you why. If I extrude, let's turn off our subdivision, and if I extrude down, you can see we get a similar sort of effect. But when we look at this geometry from the top, which is where the normal map projection would see it, you'll notice that we can't see the sides of this channel as they're at 90 degrees. So in effect, this channel wouldn't show up in a normal map. What we need to do is actually inner extrude this and then drop the geometry down so that when we go into the top view, this edge is visible to the normal projection. And you'll want to consider this with any kind of detail that you make should have these kind of non-90 degree edges on it, whether you're extruding up or down, so a normal map projection can see them. And that's just a quick tip. So what I can do now is just select all of these edges if I want. Go to solid mode with my bevel tool, give them a little solid chamfer. Let's select this outside edge, extrude down to create a control cut, and extrude down some more. And when we subdivide, what we get is this nice kind of inset detail around the top surface of this shape. We might want to raise the subdivision level here to improve our sharpening. And we can see that when we render, this looks like a very nice detail. And that is how we would cut that round, by using edge flow in our sharpening cuts as opposed to this termination that we had before. So that's the basic premise of adding these sharp details. You can do it two ways, either with the quads or by moving those quads back a loop and cutting detail like this. And different situations call for different applications, so it all really depends on your topology how you work this out. These kind of edge cuts can be actually useful for another kind of effect. Let's say I take a cube here, just make kind of a brick shape. make this editable and just get rid of this bottom polygon here. And what I'm going to do is inner extrude this like so. And what I might actually do quickly is just put this into a double symmetry by connecting these edges, grabbing these polygons UI, delete and optimize, so I'm left with one corner. Go symmetry, put this into another symmetry object on the XY, and now I have my shape back, but I only have to deal with one area. Obviously a very fast way of working. Now I can create quite a nice transitional curved effect. So what I'm going to do is I'm going to grab these edges here. I want to say that this is just one way that you can do it. Grab my slide tool and clone this edge like so. Then I'm going to come and grab these edges and now clone these out like this. So now I have a similar kind of geometry where I have a loop running around here, and then I have another row of polygons set behind it with this quad in it, exactly the same as what we had before. So what I'm going to do is add a loop cut around here, and I want to make this edge the same distance away from this transitional edge as this edge is here. Now when I subdivide this, you should see this kind of detail happening, which is quite nice. I'm going to display my subdivision with isopalms here so you can see what's going on. So what we're doing is getting some nice curvature where these control cuts are quite a ways away from our transitional edge, and then these edges running down here are sharpening this corner, the result of which is this kind of effect, which can be really useful in all sorts of applications. And we also have a loop running around our transitional edge because we have obviously edge flow running around both of these surfaces. And we could always grab our bevel tool in chamfer mode with a few subdivisions and set our own curvature up if we wanted. We could even give this a few more iterations and take the depth down and our subdivision off. Bring this in a little bit tighter. You can see we can start to get these kind of effects too. I could always take this transitional edge here, solid chamfer that to sharpen it up. Now since these edges are pretty close to our transitional edge, I could just get my knife tool in loop mode and just cut a similar edge. Into here to sharpen the top up, and you can see we get quite a nice result from that. This effect aided by these control cuts running down this initial inner extrude that I did on this surface.